Howdy folks, we are looking at section 1.6 now for pre-calculus, and so now the first part of this is just looking at a lot of basic functions, or they like to call parent functions. So there's typically no alterations to these graphs, but there are some in one of them. Now we're going to be looking at how we can transform them in the next section, so you'll want to have down what these look like in their normal unaltered form. So we can start with our first one, our constant function, which would just be like y equals a number, so or f of x equals a number. So in that case, we're going to have just a solid horizontal line, and we can have some different information about that line, so we know the domain is all real numbers. In this case, since there's only one y value in the entire range, then they'll just focus on that one value with the curly braces. You can see it's constant throughout, and then there's also symmetry about the y-axis. Now our identity function, so y equals x, is going to look something like this. We have our domain and range, both all real numbers, and we have it's increasing throughout. And then the other thing we can also say is that it is symmetric about the origin. Our linear function now starts to look at some transformations to our identity function. So you can see that we got 3x plus 2 in here, so it does kind of change the look of our line, but we still have a lot of the same features. The domain and range is all real numbers. Now the increasing and decreasing aspect of it will change based on what we have for numbers in front of our x, which we know is our slope. So obviously if the slope is negative, it's going to be decreasing throughout, but if it's positive, it will be increasing throughout. So that's something else we know. And typically if there's a shift away from the origin, could be to the left, to the right, up or down, it's going to lose its symmetry. So that's why we don't have anything listed there. The next group, excuse me, we have our absolute value function. This is a pretty powerful one. It's going to look like the absolute value of x. And so we know that the y values cannot be negative. So you can see that once we get to 0, we start getting on the negative side, it bounces back into the positives. So we have our domain in range. So our domain is all real numbers. Range is only positive numbers, including 0. So we have the square brackets there. Increasing only from 0 to infinity, and decreasing on the left side from negative infinity to 0. And we can see that it is symmetric about the y-axis. Our square function, our standard parabola, usually it's centered at the origin, and so we can see we have our domain is all real numbers, and we have our range is only just the positive numbers, including 0, and then our increasing and decreasing and symmetry. Our square root function, you can see, is our standard square root function. Domain, all real numbers, only on the positive side, obviously, including 0. Same with the range, and it's increasing throughout. So again, you do want to try to memorize these. We still got a couple more on the next page, though. So let's take a look at those last two. We have our cubing function and our cube root function. So both of these are very similar in how they look, and they do have some similarities between their domain and range. They both have all real numbers for both of those, increasing throughout on both of those, and they both have symmetry about the origin. So again, all ones that you just want to try to commit to memory. Okay, so let's take a look at some problems that you'll see in this section. So the first one we have, for each part, write the linear function f that has the given values, and b sketch the graph of the function. So we got f of 1 equals 4, and we got f of 0 equals 6. Now remember, this is another way to describe the x and the y value for a specific point on this function. So we know that when the input is 1, the output is 4. So this basically tells us that we have the ordered pair 1, 4. This one tells us we got the ordered pair of 0, 6. So we know we have those 2 points, so now we can create our line. our linear function. So we do have the y-intercept. So because of that, we're halfway there. So the only other piece we need is the slope. So we can find that pretty quick just by substituting into the slope formula. So we can say 6 minus 4 over 0 minus 1. And that looks like it's going to be 2 over negative 1, which equals negative 2. So now we have our slope. And so we can put it all together, and we'll have, and we want to use f of x form. Instead of y equals mx plus b, we'll use f of x equals mx plus b. So negative 2x plus 6. All right, so there's our linear function. So now we just have to graph that. So we know we have a point here at 0, 6. We have a point at 1, 4. So let's put that point in there as well. And we can maybe put in a couple more just to make it easier to graph. So now we have our line should just slide right through all those points. And there we have it. Now this one is a little bit messier just because we have fractions, yay. But we can still do the same kind of things we did over here. So we know we have a couple of points. We don't have the y-intercept, so we're going to have to use one of these points and use the alternate form, the point slope form, to find the equation of the line. But first we need the slope. So let's do that first. So we got m equals, so we got y2 minus y1, so a negative 5/3. And then we want to subtract the x values. So we got 6 minus 1/2. All right, so now we just have to simplify this down. So 2 plus 5/3. So 2 is the same as 6/3. So 6/3 and 5/3 is 11/3. And we want to divide that by 6 minus 1/2. Well, 6 is 12 halves. 12 halves minus 1/2 is 11 halves. And so now we can rewrite this if we do our same switch flip. And that gives us 2/3. So 2/3 would be our slope. And so now we have our point here of 6, 2. X value is 6, y value is 2, and now we just have to plug that in. So y minus 2 equals 2/3 times x minus 6. And so now we just have to break it down. Now remember, we're going to change the y into f of x when we're done. So we got y minus 2, 2/3 x, 2/3 times a negative 6 would be a negative 4. And so now we can add the 2 to the other side. And let's change it to f of x. So we got 2/3 x plus, oops, not plus, but minus. Everybody makes mistakes. Minus 2. All right, so now we're good with that one. So let's plot our y-intercepts, which we know is 0, negative 2. And we need a slope of 2/3. So up 2 over 3. Up 2 over 3 would put us right here. And we can repeat that in both directions. And there we have it. So that's kind of the first step with this section. We're going to see some more problems in the next video. Stay tuned.